Oh, were they from? Oh, yeah, they did. What did you say, Malay? Are you mad with me? I'm sorry. Okay. 19, you said 19. Did somebody say 19? Yeah. All right, let's do front page first. How about that? Front page, 10. All right, the end of an hour hand on a clock, so let me just draw a clock, is 5.5 centimeters from the center. So that's my radius, right? How far will the hour hand travel over 3 full days? So whenever it starts clicking around, right, that's 360 degrees, or if I put it in radians, because I'm going to have to be in radians, that's 2 pi. But it's going to hit that not once, but twice in a day, right? Because you got 3 o'clock a.m., and then you got 3 o'clock p.m. You will too by the end of the class. But that's unit circle, and you'll just wait. You'll know that easily. By the end of this class, you'll know. That's when you'll know. And then convert it over. That's fine. All right, but it says over 3 days, right? So every day it goes 4 pi. So 4 pi, 4 pi, 4 pi gives me a total of 12 pi. So my theta is 12 pi. My radius is 5.5. If I want to know how far it traveled, then that is 12 pi times 5.5, which would be 60 plus 5, 65 pi. Oh, 66, sorry. I didn't take half of 12 correctly. Inches. Yes, how do you know it already? You already learned it? Nice. I'm glad that y'all are so conscientious about the units, because that's a big deal when we get to calculus. If you don't have your units, you don't get your points. And sometimes you get points just for putting the correct units, even if your answer's wrong. Yeah. Y'all are so excited about this project.
Don't say your idea.
All right, yes.
No.
18. A circle with radius of 15 yards, 15 yards, contains a sector with an area of 609 square yards. Find the measure of the central angle. So to find area, remember that's 1/2 r squared theta. I have r and I have area. So that's really what I'm doing here, is determining what I have and what I need, right? So the area is 60. The radius is 15. Sorry, y'all. Sorry. My bad. So this is 609 equals 225 over 2 theta. I'm going to multiply by the reciprocal. You probably did all this on your calculator, which is A-OK. But 2 over 225 times 609. Don't tell me. 1218 over 225. Does it simplify? Okay, you can say it now. I know 3 will go in there, I think. What's it simplify to? Okay, y'all can tell me the answer now. 406 over what? It's radians. It's always in radians. It's always going to give you your answer in radians, and it's always you're going to input in radians. So now I have to convert. So if I convert 406 over 75 into degrees, which one, Harris? 180 over pi or pi over 180? What do you think? I'm converting it to degrees. That's what you meant to say. Yeah. All right, which gives you what? What you want, you do what you want in the top. So this is degrees over radians, so you want degrees. What did I get? Did you do a decimal? That's okay. Sorry. Yeah.
Okay, now 19.
19. Oh, I like 19.
I don't. I just have no. You got it.
It's a lot. It's a lot. All right. I'm going to draw a picture for 19 because it helps me. A wall clock is equally divided into how many sections? 12. Here's 12, 6, 3, 9. Okay. There's my center. If the clock reads 8 o'clock, okay, so what does 8 o'clock look like? 8 o'clock. Everybody okay? So this is my sector area I'm talking about. Okay. And has a diameter. Now be very careful because diameter and radius are two different things, right? Diameter is 12.5. That means radius is 6.25. You divide it by 2. All right. Find the area. Oh, hold up. Mm-hmm. They gave it to us. Find the area of the smaller sector formed by the minute and hour hand. So we're talking about this one. Take the diameter and cut it in half. Diameter goes all the way across. You with me? Okay. So I need to know my theta, right? How am I going to find theta? How many degrees is all together? Whole circle though. 360, right? So if it's 360 degrees all the way around, and I take 1, 2, 3, 4 equal sections, divided by 4. So 360 divided by 4, which is, what is it? No, that's not right. 1, 2. That's right. What am I doing? What am I doing? 360 divided by 12 would be 30, which means each little section is 30. 30. So my theta here would be 120 degrees.
I thought it was.
Is that? Oh, because
It said the smaller sector.
I think drawing the actual plot drawing.
It does help. It does help. Now I got to put it in radians, so I'm going to need to multiply by pi over 180. 12 over 18 simplifies to 2/3, so 2 pi over 3. Now I can plug in that formula. 1/2 radius is 6.25 squared times theta. And I don't know, somebody else can tell me what this comes out to be, because I don't know. What is it? That should be what you get.
Wait, okay,
So do 6 point, yeah. So this is, your area is 1/2 radius squared. So I plugged in the radius from up here and theta. You don't know how did I get the number? On your calculator, do 1 divided by 2 times 6.25 to the second power, and then times that by the 2 divided by 3. And then do math, enter. And we just left the pi in there. We didn't, yeah. Area is always in the whatever units it is squared. The pi, yeah. All right, yes, no, maybe so. Yep. All right, right triangles. That's what this is going to apply to. If your triangle's not right, it doesn't work. What is a right triangle, first of all?
90 degrees.
It's got 90 degrees, right? So this is only working whenever one of my angles is 90 degrees. That's a right triangle. Doesn't matter where red it is. It just matters that it's there, right? All right. Now, have y'all ever seen this before? Yes. Some of you have seen SOHCAHTOA before. Okay. SOHCAHTOA. So this is how we're going to remember our trig functions, okay? I'm fixing to show you. So we have 3 trig functions, and everything branches off of those 3. They are sine, cosine, and tangent. Okay? Yeah, I'm sure you've seen it at some point. All right, so we have. I'm trying to think of the little acronyms that my kids have. Some old hag cracked all her teeth on apples. Some old, I used to have a little contest in my classes to see who could come up with the best acronym. And that one stuck, and then another one, well, it's probably not. It's probably not.
I had that one.
What? He said SOHCAHTOA. It sounds like one of my answers.
Theta to go from, or they give me a theta. So that's what you have to remember. Theta is your trig functions are relative to your theta. Theta is always one of your acute angles. They've got to be less than 90 because you've already used 90. There's how many degrees altogether in a triangle? 180. So these two together have to. So thetas are always acute. They're always less than 90. And so based on that theta is how we determine where our trig functions, what the ratio is. We use this little acronym because it helps us to remember. The sine of theta is equal to the opposite side divided by the hypotenuse. That's where your sine comes from. So I need to, I guess, define on my triangle here which side is opposite and which is hypotenuse. So if you're at your theta, your opposite sine is the side that never touches the theta. So look directly across from it. This would be my opposite. This, of course, is the what? Hypotenuse. And then you have an adjacent side, which is the side that it touches but never the hypotenuse. I hope that you've at least seen this at some point in geometry. This, of course, depends. If my theta was at the bottom, then my opposite and adjacent would be flipped. Okay, so it depends on where you're starting from and what your theta is. Theta. Yes.
It's opposite over.
It's a ratio of numbers. Yes, because it's opposite over hypotenuse. The same for the rest. So the cosine of theta is adjacent over hypotenuse. And what do you think tangent would be? Opposite over adjacent. Now, you guys have probably seen these at some point, right? You've seen the SOHCAHTOA, at least maybe you don't remember them, but you've seen them. If you hadn't, it's pretty easy, right, Armando? Pretty easy. But there's 3 more based on these that I need to show you, okay? Those are cosecant, which we abbreviate as CST, okay? Cosecant is just the reciprocal, we call these reciprocal trig, the reciprocal of the sine function, okay? So if you take sine and you flip it, you get cosecant. So if I want to know what's the cosecant of theta, what would you tell me? Hypotenuse over opposite. Okay, that's your first reciprocal function. Your second reciprocal function, reciprocal of sine, which means flip sine over. Which one? CSC. You talking about right here?
No, what is it?
Oh, the whole word? Cosecant. C-O-S-E. It's backwards from what you would think. It gets confusing. All right. Secant, which we abbreviate as SEC. By the way, SIN is an abbreviation. It's really SINE for sine, but we abbreviate it SIN. Yeah. Doesn't matter. Secant is the reciprocal of cosine. So notice this is going to get kind of confusing, right? Because cosecant and sine go together, but secant and cosine go together. Cosecant and sine are flips of each other, and secant and cosine is the opposite of what you would think. So you've got to keep that straight because that gets very, very confusing. So secant of theta is what? Hypotenuse over adjacent. And then the last one, and we'll just be working with these 6 today. I'm saving special right triangles till tomorrow. Do y'all remember learning special right triangles? Thursday. 45, 45, 90, 30, 60, 90. Maybe Friday. It won't be Thursday because I won't see you tomorrow. All right. The last one is cotangent. We abbreviate it COT. Guess what it's the reciprocal of? Tan. It's the easiest to remember. SOHCAHTOA is what you have everything branches from your sine, cosine, and tangent. So cotangent of theta would be what? Adjacent over opposite. That's such a flex. I'm good at Minecraft sound.
That's what he wants to do.
Yeah. Hey, my name's Brett, and I'm really good at Minecraft sound. You want to go on a date? Yeah, what do you?
That's good.
All right, couple things to remember. And I feel like with what y'all are telling me about geometry, I might need to go over this. If you have a right triangle and you are missing one side, okay. In other words, yes. How could I find the missing side of my triangle? Pythagorean theorem. That works with every right triangle, right? That is a squared plus b squared equals c squared. C is always the what? Hypotenuse. These are always legs. They're always the two that come in at 90 degrees. So if I need to know what the missing leg is here, set it up. 20 squared plus b squared, because I'm missing this other leg, equals 29 squared. So use your calculator. Yep, it doesn't matter which one's which. They're just legs. Yep. So do 29 squared minus 20 squared. It doesn't matter which one you let A and B, as long as they're both legs. B squared equals what? 400. Is that a perfect square? Now, if I didn't get a perfect, that's not right. If I didn't get a perfect square, I got to rewind back to my Algebra 1 and Algebra 2 skills of simplifying radicals there. I know. All right, but let's do some identifying trig functions, and we'll just use this triangle since we've already found a missing side. Are y'all ready? Let's let this be theta. So, Malaya, tell me what the sine of theta is. (20 over 29). That's exactly right. How did you get that? If this is, all right, if this is theta, then opposite is 20, hypotenuse is 29. Yep, always look from your theta and then find the side opposite for the opposite. But you're always going from your theta. It will, yeah. Opposite over hypotenuse. This is just sine. This isn't secant, just sine. All right. How about cosine of theta? (21 over 29). That's exactly right. It's marked. We mark it. It'll be marked for you. For these, we're using exact values. We're not going to use decimals on these. We're going to use exact fractions, okay? How about the tangent of theta? 20 over what? 21. How about the cosecant of theta? Which one is flipped for cosecant? Sine. 29 over 20. Yes? How about the secant of theta? I'm flipping cosine for this one. And then cotangent, tell me what you think. Let's do another. Find all 6 trig functions of theta. Mark that down.
Can I just draw a regular?
If you want to. Just make sure your theta's in the right place. All right. All 6 trig functions. Boys. All 6 trig functions. Sine, cosine, tangent, secant, cosecant, and cotangent. Go. You got to find it. Huh? Is this what we're learning? Yeah. What don't you understand? Remember SOHCAHTOA. Right.
What is it about?
Sine is opposite hypotenuse. Cosine is adjacent hypotenuse. Tangent is opposite adjacent. All right. Shh. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, Armando, you asked me this and you're not listening. Tangent is opposite over adjacent. Yeah. So that'd be 36 times 3. Wait. Finding the hypotenuse? Yeah. All right, I'm going to get us through finding that hypotenuse on that triangle and then letting you set up the rest. Okay, so 6 square root of 3 squared plus 6 squared gives me my hypotenuse squared, yes? So this would be 36 times 3 plus 36. Guys, there's lots of talk. This is not easy stuff, and it is brand new. All right, 36 times 3, 18, carry 108. So what is the hypotenuse? 12. What you got? Yes, so you square both pieces in here. So 6 squared is 36. The square root of 3 squared is 3. Yes. All right, Armando, you got your 6 trig functions? Well, I need you to pay attention. Opposite is 6 root 3, right? Yes, yes.
Are you done for the moment? Are you done for the moment? Can I look at your notes really quickly? So when we do it, do you want us to put like 6 square root of 3 or do you want us to put the simplified version?
All right, so let me show you guys because this one's got a radical in it, so it's a little bit different. So you got to go back to those Algebra 1, Algebra 2 skills on this. So for this one, the sign, remember SOHCAHTOA, right? Opposite over hypotenuse. What's opposite of theta? 6 square root of 3 over 12. What I can simplify, I need to simplify. What's 6 divided by 12? 1 over 2. So I get square root of 3 over 2. You can put 6 divided by 12 in your calculator, yeah. Mm-hmm.
So you're finding everything.
Right. How about the cosine of theta? 6 divided by 12 is 1 over 2. Divide both of them by 6. All right, cosine is what? What's adjacent? 6. What's hypotenuse? 1/2. Tangent. That's your TOA. Opposite 6 square root 3 over what's the adjacent? 6. It's just square root 3. No, opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Yep. All right, we're going to flip them. But wait. That's exactly right. And I'm glad you said that, Malaya, because that's what we're going to have to do. So if I flip sine, all right, so cosecant and sine are the flips of each other. So if I flip it, you're right, I get 2 over square root of 3, but I've got a problem with that because I can't have a radical in the bottom. How do I get rid of it? Square root of 3, square root of 3. So I get 2 root 3 over 3. Say that again. Cosecant flips sine, secant flips cosine. I just took the simplified version. I took what was already there and I flipped it. You could have, guys, this is getting incredibly hard for me. This is new stuff. If you don't care about it, then look somewhere else. If you wanted to, you could have used hypotenuse over, so 12 over 6 root 3. You would get 2 over root 3. And then I could simplify this way. I just took the already simplified one and flipped it. Either way is fine. So you can't have a radical in the bottom. So you multiply the top and the bottom by that radical. And you get 2 root 3 over 3. You just reciprocate it. You flip it. Square root of 3. But then you got to multiply top and bottom by square root of 3. Yeah. Yes, which is 3. Yes. So, I think y'all are jumping ahead to tangent. You get secant is 2. That's the flip of cosine. But cotangent, if it's square root of 3, and I flip that, I get 1 over square root of 3. And so I can't have that radical in the bottom again, so I root 3, and I get square root of 3 over 3. So here's my 6 trig functions. 1, 2, 3, 4, 5, 6. Then you canceled it. That's fine. That's fine. You did it as adjacent over hypotenuse, which is fine. Yeah.
I know I do have to go back and watch the video.
How did you get second?
So what you do is you flip it, but if the radical at the bottom, you're gonna have to multiply it together and then find the square root of that.
Right.
Okay, that
Right.
makes sense. And you just do it for the alternate.
Right.
Oh, I read
Yeah. Yeah.
Okay.
Y'all look so bored. Kenzie does that with me all the time. I don't know yet. I don't know. I got to think about it. Let's see where we land today. Find all 6 trig functions of theta.
Oh, Chase.
Yeah, Chase, don't do that.
Chase, that hurt my feelings.
That's okay. I don't have feelings anymore. I've been teaching high school too long. But it's funny because y'all see what to do. You're just mad that you have to do it, but you know what to do. All right. Okay.
Wait, let me try.
All right. Tangent is opposite. All right, listen, pay attention. Tangent is opposite over adjacent, yes? Set up your triangle, find your theta, and find your missing side. Go. It doesn't matter as long as you put the opposite and adjacent in the right place. If you put your theta here, then your opposite is going to be down here, and this will be your adjacent. But if you put your theta down at the bottom, then your opposite. I think I'll put mine at the bottom. It doesn't matter. It doesn't matter. It doesn't matter. Your ratios, you're still going to get the right ratios so long as you label them correctly now. So if your theta's up top, your 7 and 24 should be switched. Yes, you have to find the hypotenuse. So this is the same. Now it's the same thing you've been doing. You just had to interpret the tangent. Somebody's going to have to tell me what that is because I don't know. C is 25, 625. I feel like I'm picking easy examples and I don't mean to. I didn't mean for it to come out. Understand if this wasn't a perfect square, I might end up with something like I had before where it was like 6 root 3. All right, so this is 25. Now find your trig functions. 5 because you were given 1, right? I was given tangent, so cosecant. Never do decimal